That's good to hear. Thank you. Thank you. Appreciate that. All right, we are live. So today's date is March. Yay! It is March 1st. Oh, hallelujah. So today what we're going to do is this. We want to look at a quadratic regression. So what we're going to do is use our calculator to find quadratic regression y equals some ax squared plus bx plus c. Okay? Huh? Oh, you guys didn't get it? Right here.
Do you have any more calculators?
You can borrow mine.
We'll
share. We'll share, okay?
Yeah.
Yeah, you guys, you borrowed them last night and you didn't bring them back.
I brought mine up.
You are so awesome. So if you did not bring them back from yesterday, here's one. There's one right here. One there. Right. Yeah, if you guys don't mind sharing. So we have three different forms from prior notes. For the vertex form, we have standard form, and we have x-intercept form, right? In our warm-up, we practiced our vertex form, and in our warm-up, we practiced our x-intercept form. If you want to take a picture and borrow my notes someday on these, you're welcome to. Okay? So, if I take a look at this particular example, I have more than just 3 points. Yesterday, we had 3 points. This was yesterday. And yesterday what we did was we made our 3 equations from our 3 points. We created our matrix, right? And we solved it using the calculus with A inverse times B. But with more than 3 points, you really can't do this because we can't have a matrix that big. So we do it a little bit differently. And we've done a regression line before. We did this with our linear regression. The only difference is we're going to do a quadratic regression. Yes?
Why can't we make a matrix that big?
I knew somebody was going to... Oh, you didn't ask the question. I thought you... You can. You can. They'll be mismatched in this case because they have one of them has to be a square matrix.
Okay.
You didn't ask the question I thought you were going to ask. That's good. So now, let's take a look at this. So, I'm a track coach. So I just made this problem. I thought, what if you grabbed a bunch of people off the street and timed them in the 400? Of course, they'd be very happy to do that, I'm sure, right? So let's say I grab a 10-year-old, I time a 10-year-old, I grab a 13-year-old, I time that person. As I go up, age 15 is pretty fast. A 22-year-old is even faster because, you're at the prime of your sprinting age, and then we get older, and we get older, and we go slow, and then somebody as old as me kind of sucks, and that's just the way it is. I don't run the 400 anymore. It would probably just about kill me. So, let's make a scatter plot. Scatter plot. So, I'll put age down here. We'll let the x-axis be age, and I need to get all the way to 5. So let's see. Maybe if I go 10, I'll go by 5s, 10, 20, 30, 40. That'll probably work. I'll go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and then 60. Okay, I'll just probably the easiest scale to do. And I'll let time be my dependent variable. And because the times are all above 50, right? I'm going to do a squishy first. I'm going to show you what a squishy is. It's not really called a squishy. It's not really called a squishy. I call it a squishy. It's compression. So I compressed from 0 to 50 here. Does that make sense? I compressed. So the first 0 to 50 has been compressed. And that way I can see the part of the graph I need to see. Okay, now I need to get up to 130, right? Let's see, 60, 70, 80, 90, 100. That'll probably work. 60, 70, 80, 90, 100 seconds, 110, 120, 130. Yeah, that'll fit. And I'm just going to do a scatter plot, dot to dot, right? Just plain old dot to dot. So I'm just going to go age 10, 123 is about, it doesn't have to be perfect, but about 123, about there. 13, age 13, I'm just trying to get it close. Oh, 105, which is about there. Age 15, I'm at a 68, about there. Age 22 is about a 55, should be about there. Age 30 is about 61. Age 41 is about 70. And age 55 is 130. Yeah, do you need colors? Yeah, I got lots. Grab whatever you want from here. And of course, also on the desk, I got lots of colored pencils. I like colors too. I agree. Well, it's got to be a quadratic. It has to be, because we all would agree that a little itty bitty baby is going to run a super slow time, right? And somebody as old as me is going to run a really slow time, right? But we know that somewhere in here, in this parabolic model, and don't draw this, I'm going to, but there could be some parabola that might fit in here, right? Does that make sense? Don't draw that, but there could be some parabola. What we want to do is find the equation of that parabola. Now there's several points, so we are going to use a different part of our calculator. We're going to use our statistics again instead of our matrix. We're going to go back to our stat. And we've done this before. So we're going to go into our stat, and if you have a messed up, fouled up calculator, let me know and I'll see what I can do to fix it. How's that? Okay. So I've got my stat. I push the stat button. We've done this. This is going to be helpful. I want to put in my numbers, so I'm going to go to Edit. Please tell me if I'm going too fast. Please. So I'm going to go to Edit and I go Enter, and I need to put these numbers in my calculator so I want to clear my list first. I'm going to clear list.
How do you clear it?
So I highlight the list. So see, up, down arrow, I highlighted the list name. I'm going to push clear, down arrow, clear, down arrow. So I'll do the same thing. I'll highlight list 2. I'm going to highlight list 2. I'll push clear, down arrow.
Are
Okay.
we entering the age first?
Yes, age is going to be my control variable. And then, so list 1 is going to be age. So I'm just going to then enter data. So enter data L1, L2. L1 and L2. Now if you have a calculator that doesn't show an L1, it shows L2, we'll just make sure we know what lists are going into. Anybody not have an L1, L2? Okay, good. So we're just going to go 10, enter, 13, enter, 15, enter, 22, enter, 30, enter, 41, enter, 55, enter. Go list 2, 123, enter, 105, enter, 68, enter, 55, enter, 61, enter. Oh, what did I miss? Oh yeah, thank you, Michael. Shoot, come on. There we go. Thank you, Michael. Okay. So if you have more than 3 points, they won't line up completely. Some of the points will be near my graph, does that make sense? But not on it.
Line of best fit.
It is the line of best fit. So the next thing I'm going to do is find the equation. So I'm going to go back to stat. I'm going to hit stat again. This time I want to calculate an answer. So I go over to calculate. And I'm looking for the quad reg, because it's a quadratic regression line, so I'm looking for quad reg, which is number 5. So I'm going to go to the quad reg.
Why is it called a quadratic?
Well, it's called a regression line, and they call it a regression line quadratic because a quadratic means x squared. Anytime you hear the word quadratic means x squared, it's a regression line because it averages the point. It does a thing called a regression, okay? I'm going to push enter, right? And then I'm going to go to calculate.
You did bar.
Oh, I did. I can tell because list 1. Stat, calculate, quad reg. There we go. Go down to calculate, right, and then enter. And I should get A, B, and C, right?
B, C, and then R2.
Yeah, and R2 is important also. Okay, so here we go. I've got, oh my gosh,
Yeah, you got it right.
quad reg, enter. There we go. So I know in my answer, my A is, we'll round up, 0.14. I've got B is negative 8.65. And C is about 185.78. Okay, did you guys get those answers? Yes? And we'll talk about the R2 in a minute. It doesn't give us an R, it gives us an R squared. It won't matter. Now, my answer, right? So since it's a quadratic model, it should be y equals some ax squared plus bx plus c. And then all we have to do to get the equation, the best fit equation of this line, is just to put a, b, and c in from our calculus. So I'm going to take these values of a, b, and c, and I'll put them into my quadratic equation. So I'm going to rewrite this as a y equals a 0.14x squared plus a negative 8.65x plus 185.78. Okay, now that is the equation that would fit the best. Now you don't have to do this piece, but I'm going to show you something that the calculator will do, which is kind of cool. If I plug in my y equals my 0.14, you don't have to do this, but I want to show you x squared. If you really want to know how to do this, I can show you later. 8.65x plus 185.78. I'm going to go to my scatter plot and turn that on, and graph. I'm going to change my window significantly. Hold on. So the calculator will do a scatter plot, and it's also going to show my equation. I want to show that to you as soon as it's done. Window, make my window fit this. Let's go from 0 to 60. Let's go from 50 to 130. Now graph it. Okay, check it out. Okay, now it's a cool feature the calculator does, right? You see that? Isn't that cool?
What?
Oh, there's something else on there. You don't have to know how to do this. If you want to know what I did, I'm happy to show it to you. What else is on there?
That is amazing. Wow.
Graph. Isn't that cool? Yeah, and you don't have to do this. However, what it shows me is that's the best fit I can get. And it's not perfect, is it?
No.
Now, if I asked you this, easy question, because it's the next question, where would be the fastest? Looking at my graph, where's the fastest?
At the lowest.
Which would be the vertex, right? You guys agree? The fastest is right there. You guys agree?
Yes.
So my fastest is at the vertex. And the way I find my vertex is with my negative b over 2a, right? Now the vertex is a point, and the point is going to be age time, right? So right now what we're finding is the age, because that's the x value. So my vertex is age time, so let's find the age. Negative b is going to be a negative negative 8.65 divided by 2.
Then you positive, right?
Yes, totally right. Times, yes, 0.14. And I'm just going to let my calculator do that work for me. I'm going to go, like you said, positive. Totally agree, Camille. Positive.
Who's that?
Oh, no, sorry, Jose, right? Juan.
That's my name.
Juan, yep.
That's my name.
Ariel.
Oh, yeah.
Yeah, sorry, you guys. 2 times 0.14. Boom. So 30.9. So T equals 30.9, or about 31 years old, which is actually pretty close to the truth. For the Olympic stars, they're right about this age. They've spent their whole 20s training. They've gotten faster and faster. They hit their world records about this age, and then they get slow.
How old did you say both?
I'm going to look that up when we're done. Yeah? Yeah. I think he was pretty close to 30 when he did it. Okay? Yes. Yes. Want to take a picture of that? Okay. So then, we know the age. How do we find his time or her time? Plug it in, right? So we want the time, we just plug it in.
Thank you.
Okay, so then, if I want to find the time, I plug it in. So the time will be,
Wait, I thought that, I'm confused, I thought you just found the age.
I did, and that was my bad. Now the time, we plug it in, right?
Would we round that age up to 31?
I would be okay with that. I would be totally okay with that. In this case, it seems reasonable, doesn't it? Because we're talking about somebody's age, right? Okay, so I'm just going to use my calculator to get that value. And I'm going to go my 0.14 times my 30.9. And if you want to round that up to 31, that seems very reasonable in this case. Squared. Subtract 8.65 times my 30.9 plus 185.78. And I get an answer of 52. That's a pretty good time. 52.1 seconds. That's a good time for the 400. All right, now, before I finish, and I'll let you guys write all this down. Before I finish, we'll talk briefly about 4 different ways to get our answers.
4 different ways?
Yeah, and you already know 3 of them. Okay?
What's the easiest way?
Depends on the question, doesn't it? And that's what I want to say. I couldn't have said it better. Who asked that question? Yes.
Jose.
Totally. It depends on the question. So if you have a vertex, you would use y equals a x minus h squared plus k, correct? If you know the vertex. If you know the x-intercepts, you would use y equals a times x minus h times x minus k, right? If you have 3 points, to get the exact answer, you're going to use our matrix. And you're going to go matrix A inverse times matrix B. If you have more than 3 points, yes.
What was the time again?
52.1, I think. 52.1. There it is. Yes. So if you have more than 3 points, we're going to use our stat and our quad regression. I've got a worksheet for our homework, and I'd like you to work on it while we're here because I can help you, right?